So I am recording in the class of all the Houston Texan losers. I just want to throw that out there. It's just so funny they lost. I know. I won't come to class that day. All right. So how do we know this is a one-sided limit? Because that rock chair, that up there, so that plus means that I'm coming from the right-hand side. It's kind of a shame. I mean, it makes you wonder, and no, I'm not that old, but back in the old days when they didn't really have good ways to graph, that you couldn't find this stuff, as readily as you can now. And to me, it's kind of difficult to teach this stuff now because it's so easy for you just to go graph it and say, why do I have to go through all this other junk? Because I can just look at the graph. Well, you have to go through all that other junk because I had to, okay? And my grandmother and grandfather and great-grandparents, no, I don't even think they took calculus. Okay, but into your heads to graph these functions, okay? So if I graph this, and most of you are looking like, man, that's kind of strange, but hopefully you kind of recognize this jump at -2. Coming this way from then it appears the limit is 1, and I'm done, okay? In my math lab land, and you guys have no idea. First of all, you email me during the Cowboy game, and then you email me, I'm not looking in anybody's direction, and the subject line is, my math lab hates me. And so I'm like, I have another beer to that one. Yep, yeah, my math lab hates you. And so in a perfect my math lab world, you put 1 in and you're done. Okay. Unfortunately, in this class, though, I want you to go through a formal proof, which means in this case, and it's not that formal, really, it's logically thinking, so it's kind of nice to see here, this number line. If I start plugging in values, like let's just start right here, -1.5, -1, notice that is going to always be positive for values greater than -2. Why do I say greater than? Because we're coming from the right side. So they'd be greater than this value. So I can replace this simply with the positive x plus 2, which now makes it nice. That cancels. And again, these slides are already in Blackboard. And so this cancels, meaning it goes away. And so now I get to the point, remember what we do with the limits. Every step we say, can we plug that in? Can we plug that in? Can we? Aha, I can plug. And so I simply plug in -2 and I get my answer. Okay? But still, it'd make me so happy if I saw you guys graphing this stuff, to check it, especially on a test, to make sure you're kind of on. And, I have a lot of students will tell me that they reverse engineer things. Like they'll go into my math lab and they'll miss it on purpose just to get the answer and try to work backwards, which is weird, but, that's kind of what I'm doing with graphing, is I'm saying, oh, well, I know this is going to be my value, so that kind of helps me lead me in a direction to, do this. All right, well, let's now come from the left side. The graph, it looks like the answer is -1. Again, you're doing your homework in my math lab. It's a perfect world. You put -1 and you're done. But then you come take the test, and I want to see why it's -1. And if I look at values less than -2, so -3, -4, this piece here, the negative of x plus 2, as that cancels, that becomes negative. And now I'm to the step where I can just simply plug this in. So I do, and I get -1, okay? And that's pretty much